talks are really, really high quality, which makes me a bit intimidated about my talk, but it's better when someone talks to you rather than when you read a blog post or something like that, so you can discuss and go deeper in the topic.
Just to keep track of everything executing, like a help. This is a mess.
It's a collective of people that is actually coming and wanting to do change. When you're out there in society or in your town, you maybe don't find these people. Because here is where it starts, sharing knowledge, but not only sharing it, but to actually act on it.
Well, it's great to be here. This is my first Øredev, and boy, you've got a full house. This is very impressive. It's hard to look at that today and realize how cutting edge it was at the time. I don't know, I'm sure some of you are longtime developers like myself. That was actually the world's first massively multiplayer graphic world several years before Ultima Online and others became very popular. And it was a little bit too far ahead of its time, unfortunately. Quantum Link that was mentioned was the only network that it ran on. It was specifically for Commodore 64 computers. The guy who ran Quantum Link said, this is okay, but I'm going to start some new thing called America Online. I think that might do a little bit better. And that was running on Commodore 64s. There were 1 megahertz processor, had 64K of memory in the whole computer. And we had 300 baud modems. That's basically 30 bytes a second of data going back and forth. So imagine trying to support an online world and wasn't able to have more than 6 avatars in one place plus a much larger number of people who could observe any given area. But that was actually amazing for the time, and nobody really believed that it could be done except for, I think, Chip Morningstar, who was our chief architect on that. But it was a great project, and there's a lot to learn from what's happened, and that'll be part of my topic as we dive into this today.
So my name is Ben Obergefell. I work at the New York Times on the crossword puzzle app. So why a repository? Your presenter and your UI logic can be agnostic. It's all the inside baseball about getting the data. It can be easily mocked out when you're testing, and so that you can pass new data forward in an espresso test or something like that. Rotation is made easy because you can retain the repository, but not the presenter that you have that's actually orchestrating the UI elements. So when you rotate the screen, your activity recreates, you pull back your cache data, and you save yourself a network call. And then it also applies some simplicity to your logic for getting with data.
My name is Kurt Lloyd, and I develop software for NASA at the Kennedy Space Center in Florida. And today I'm going to talk to you about writing apps for Mars. So mobile app developers and other software developers, they generally take great pride in their software products, right? They often brag about the features of their products, like they might talk about its simplicity or its ease of use, or how it was designed with the end user in mind, or how efficient it is, or all the different platforms that the app runs on, or maybe how well it performs, or how their app works even when offline, or how supportable or upgradable it is. In their detailed spec sheet, or maybe in their README files, they might even talk about what language the app was written in, or they might discuss the process that their development team used and how it was thoroughly tested if their customers are focused on quality and certifications and that sort of thing. All of these features and specs can help your app stand out above the rest in the marketplace, obviously. But how would a typical mobile app or business app compare to, let's say, the onboard software for a Mars rover? What we actually do is that we plan an entire day's worth of rover activities or operations during the previous night shift. And then we upload those instructions to the rover at the beginning of the Martian day. So it's sort of like a robot to-do list that we're uploading to the robot. And then Curiosity just starts executing its to-do list every morning when it wakes up, kind of like us. Now, coming up with this daily to-do list for Curiosity every night is no small task, though. It includes a large team of scientists and engineers, and they study all the images and all the data from the previous day, and they hold a bunch of meetings to decide what they want, what they need the rover to do that following day. So not only do they decide where the rover is going to move for the day, the safest path that it will take to get there, they also decide all the images that it's going to capture along the way, and what science instruments it's going to use and where it's going to use them. Now, once all that planning work is complete, it's time for the rover drivers, yeah, they're called rover drivers, to write and test the actual rover command sequences. And they use a custom scripting language for their command sequences. And then they run these sequences in a 3D computer simulation to make sure that they're correct. They use, as I mentioned earlier, actual sensor data that's downloaded from the rover so that they can fully experience the rover's world while they're writing and testing their sequences. It's a pretty cool job being a rover driver.
Niall. I am a managing consultant with Capgemini based in Stavanger in Norway. I'm the head of cybersecurity for Norway, which means that my job is to break things. I am an MVP, an ASP Insider, Azure Advisor. Really fun titles, don't mean much for today. I love this slide, simply because every time I say to the people, I go, Niall, why on earth are you going to show people how to hack things? I'm like, why not? Like, my 5-year-old can do this. Kids are the best hackers on the planet because they will generally ignore all the rules that you put in place. This slide illustrates a lot of the different things I'm going to be showing you today, which is you can only fight the way you practice, i.e., if I don't show you how offensive tools work, you will never know what they do. So I am going to show you what it's like to handle a knife, handle a gun for a technical way, and I will show you how to really understand what it's like to be these tools do, what it's like to have them used on you, and how you should be very careful when you're using them against someone else. Which leads me to what we're going to discuss today. I'm going to show you how to do recon, how to find your way, to find vulnerabilities, to find application problems, and to understand where you need to focus your efforts. I'm going to show you how to do exploitation. How to, once you have found a vulnerability, how do you exploit it? And then I'm going to show you some other little techniques in form of social engineering and really dodgy little things. And then we might go hack a bank, because reasons. Apparently, I asked a couple of people in the audience, I said, what would you like to learn today? And they said, how to get rich. So I said, okay, we can do that.
Hi, my name is Marcus Placona, okay? So in this example, we have a client here, we have a server here, and in a normal HTTP request, what happens is the client makes a request to the server then just responds, okay? That's what a normal HTTP request is. Now, if you've been looking at what I just did right now, you will notice that I have introduced a character to this scenario here. So I was still doing HTTP requests from Android, but I have introduced a new character, which in this example, I'm using a pirate flag to talk about this new character. So what happens here is, this is a very known hack. It's a very common hack called man-in-the-middle attack. And what a man-in-the-middle attack does is, it introduces a new character in the middle, so when the client makes a request, that request goes to this new character. This new character then sends that request to the server. The server responds to that character responds to you. So as a user, as a client, you're none the wiser. You don't know what's going on here. Like, you don't see any difference, okay? The only thing is, that character over there sees everything.
So many companies right now are investing in AI, and more particularly personal assistants. Now, Amazon has Alexa, Microsoft has Cortana, Google has Google Assistant, and this is not answering. Apple has Siri, Samsung has Bixby, and Xiaomi actually has some kind of AI as well. We're going to define a name and also an invocation name. So the invocation name is going to be the name that I'm saying, Alexa, ask, in this case, Stockholm Travel, when the next, and so on. So Stockholm Travel would be the invocation name. We also have some global field. This is a audio player, video player. Is it render templates? No, it's not. We can just select no. Now we can go to interaction model. Now the interaction model has a kind of a new skill builder. So we can click that one, and we're going to get into this view. I'm just going to say, well, thank you. So now I can ask Google Home, when does the next bus arrive? And it will go into the next transportation or line intent. And just as before, we're going to get the line number, we're going to get the transport type, we're going to call the same method, and we're going to return the speech. So all of these can actually use pretty much the same code in the backend. Let's take a look at if this actually works then.
The mic's back on.
Hey Google, talk to Stockholm Travel.
Sure, getting the test version of Stockholm Travel.
To find the closest stop to your location, I'll just need to get your street address from Google. Is that okay?
Sure.
Thank you.
When does the next bus arrive?
$807 towards Gomersplan leaves in 0 minutes.
Hey Google, stop.
840.
Oh, it actually worked that time.
Welcome everyone. I think we're 2 minutes early, but I think I'll start anyway because I have a lot of things to show you. So, all right. Cool, so welcome to this presentation. My name is Laurent Bugnon. I work for Microsoft since August. Before that, I was working for another firm called Valorem. Probably deploy either through a cable or what is actually quite convenient, you would deploy to a remote machine, give the IP address of the HoloLens, and you can start debugging. Okay? Cool, so now I want to show you some demos. So I'm going to switch to that. And normally you're going to be able to see what I see. Now it is streaming through a Wi-Fi router, etc. So there is a little bit of delay, but it should not be too bad. I'm going to go slow. So here is what I see right now. I'm going to show the menu. And then I can start doing some things. For example, I can start putting some holograms. Here we go. And for example, let's take this guy. I'm going to make it float around. And then I can click on it because it's actually a video. So I can move around, and then you see that it is very stable, right? It doesn't move much. When I move, it stays pinned to the wall. And by the way, what's really cool is that the HoloLens remembers the route. Put it down there. Here we go. Now it's a little bit small. You hear the sound. The sound is actually directional. So if I move my head, I can hear it coming from here, right? And now I'm going to make it a little bit bigger. Scale up. Scale up. All right? Now there is a pipe inside. So now the cool thing you have to imagine, you could have collaboration between devices. Here I could have 2, 3, 5 people with the HoloLens seeing the same plant. I'm going to take the pipe out. Oops. Okay, here we go. So now the pipe is kind of in the plant, but it doesn't really matter. What I want to show you is that if I click on one of the thing here, I see the blueprints. Obviously, it shouldn't be inside the plant. Forgive me for that. But the blueprint is really cool because I have full HD in each eye. And so I'm able to read the blueprint, and I'm able to talk about it with someone. Okay? And now the other scenario that I was talking about, I want to go inside the plant. So I'm going to make it big. Scale huge. All right, and now I can walk around. Careful my head, okay? So this is one of those scenarios which would make more sense in a VR headset, except that here I'm happy that I know where the stage is. Otherwise I would fall down. And also I can have someone walking with me and I can see that person, which is less jarring.
Right, so everyone knows C#. So I want to talk about what's changed in C# as a language. I'm going to talk about how it's progressed over the years. So we'll just talk briefly about C# 2, 3, 4, 5, and a little bit about 6, and then we'll talk about the future of C# and what Microsoft is currently working on. So hopefully there's going to be a lot of new things here, and you'll have a lot of new things that you can introduce in your programs come Monday. The last one is out improvements. I actually found myself doing this just a few days ago when working on a project where we were interacting with legacy code that requires us to specify out parameters. Now, previously, what you've had to do is to say, well, I want an int called x, and then you say, well, out x, right? But now what you can do instead is that you say, get rid of that, and then in place say, when there's an out variable, I want you to declare the x if it's set, right? So if I run this here, of course, it's going to say 100 and 200, because it introduces those two new local variables. So we, of course, have x available here, x and y. So these are the changes that they've recently done in C# 7. They've added more features in C# 7.1, but we can kind of see a pattern here that they try to allow us to reduce the amount of code that we write. So they introduce tuples, so we don't have to create a new class. They introduce pattern matching, so we can get rid of all these if-else statements when checking types. So if we talk a little bit about what's coming next, the fact is that they're doing a lot of work on the language. By no means are they adding less features in the upcoming versions. And honestly, it feels like they're just adding, like they're doing 7.1 now, and then they might do 7.2, and then 7.3, and then who knows what they're doing after.
So today, I'm going to tell you a story. It's a science fiction story, and it occurs in the future. It's a story about courage, about exploration, and danger, and it's also about accomplishment. Are you ready? Here we go. We have just landed on the surface of Mars. I know, right? It was a fairly gentle touchdown considering what landing on another planet actually involves. The gravity here is only about 1/3 the gravity back on Earth. Of course, after a 6-month journey from Earth orbit to Mars orbit, with basically no gravity tugging on us at all, this light Mars gravity is feeling kind of heavy on my chest right about now, and on my cheeks, and really on my eyeballs. I think I'm just going to close my eyes for a minute. Large storage facility or garage. Now, once safe on the surface, the greenhouse was checked out remotely by ground controllers, and then it was activated for autonomous farming. The greenhouse came complete with automated robotic farmers, which would ease the burden of the future human crews. The ISRU plant was also designed to operate long before the astronaut crews arrived on the surface. So as soon as it landed safely on the surface of Mars in early 2032 and got checked out by controllers back on Earth, it got to work. Someday soon, when humans first set foot on Mars, we Earthlings that stay behind, we will all reap the benefits. And we will all feel very proud of that humankind, that Earthling accomplishment. Thank you for your interest, and thank you for attending Øredev 2017. Thank you for staying to the end. Good night.